Hello everyone. Now in previous lecture we find rank of matrix by using row echelon form. Now using rank in this lecture we find the solution of system of linear equations. Now this is the system of m linear equations in n unknowns. The unknowns are x1, x2, x3 up to xn. Now this is your system of equation and we have to find the solution of this system, means we have to find the values of x1, x2 and xn. Now this system we write in matrix form like this. This matrix is a coefficient matrix and this x1, x2 up to xn, this matrix is a matrix of unknowns and it is a column matrix, and b1, b2, bn is a constant matrix, and this system is denoted as Ax is equal to B, where A is a coefficient matrix and X is a column matrix of unknowns and B is a constant matrix. Now we have to find out the solution of this system. For this we require a augmented matrix. And what is meant by augmented matrix? If Ax is equal to B is a system of m equation in n unknowns, then matrix written as A comma B means it is a combined matrix of coefficient matrix and constant matrix is called as augmented matrix. Hence A comma B is equal to coefficient matrix and it is separated by the dotted line, and in that again we involve b1, b2 and bm. This is a constant matrix and this combined matrix is called augmented matrix. Now two types of systems are there. First is non-homogeneous equations. For the system of equation Ax is equal to B, if the matrix B is not a null matrix or not a zero matrix, then system Ax is equal to B is known as a non-homogeneous system of equation. Now second, homogeneous equation. Now in that B is a null matrix, therefore this system of equation is called homogeneous. Now there are two examples. Now in that 3, 2, 0 are the non-zero numbers, therefore it is non-homogeneous system of equation, and here the column matrix are 0, therefore this is a homogeneous system of equations. Now we have to find out the solution. For finding that solution we follow these two conditions, and this is called condition for consistency. When the system of linear equation has one or more solution, the system is said to be consistent, or otherwise it is inconsistent. Consistent means it has at least one solution, and inconsistent means it doesn't have any solution. The system of equation X is equal to B is consistent if and only if the coefficient matrix A and the augmented matrix of AB are of the same rank. If rank of A is equal to rank of AB, then we say that the given matrix is consistent and it possesses a solution. There are two cases for checking the solutions. If rank of A is equal to rank of AB is equal to n, and this n is the number of unknowns, the system has unique solution. If rank of A is equal to rank of AB is less than n, means number of unknown, then system has infinitely many solution. In this case n minus r unknowns called the parameters can be assigned arbitrary values. The remaining unknowns can be expressed in terms of this parameter. When rank of A is not equal to rank of AB, the system is said to be inconsistent and has a no solution. For example, we take one example and examine the consistency of the system, and if consistent, solve the equation. Means if it is consistent, then we find the values of the given unknowns x, y, z. Now the problem is x plus y plus 2z is equal to 9, 2x plus 4y minus 3z is equal to 1, and 3x plus 6y minus 5z is equal to 0. Now we have to find the solution of this system. Now first we express the given system in matrix form, that is we write X is equal to B, and we know that A is a coefficient matrix Now here the coefficient of x is 1 and y is 1 and z is 2. Therefore the first row is 1 1 2, and same thing for the second row and third row. We write down 2 4 minus 3 3 6 minus 5, and again x is a column matrix of unknowns, and here unknowns are x y z. Therefore we write here a column matrix x y z is equal to, now here a constant terms are 9 1 and 0. Therefore this is a B matrix, which is a constant matrix 9 1 0. Now we get a system of equation in matrix form. Now we write down the augmented matrix. The augmented matrix of the system is 1 1 2 2 4 minus 3 6 3 6 minus 5, and which is separated by B 9 1 0. Now we apply all the transformation on augmented matrix, and in previous lecture we saw how to find rank by using row echelon form. Now again using that concept we have to find the rank of augmented matrix. Now here we apply the two transformations, R2 minus 2R1 and R3 minus 3R1. We know that we have to make it is in echelon form. Therefore we the first diagonal, below the first diagonal element we make the 0 entries. For this we apply these two transformation. Now after simplification we get the new R2 and new R3. Now the new R2 is 0 2 minus 7 and minus 17. Now the same thing 0 3 minus 11 and minus 27. Now we got the second diagonal element is 2, and we have to make that 2 is 1. For this we divide second row by 2, then 1 1 2 9, then 0 1 minus 7 by 2 minus 17 by 2, 0 3 minus 11 and minus 27. Then below the diagonal element, second diagonal element, we make this 3 is 0. For this we change R3 minus 3 R2, means we multiply the second row by 3. Then after solving this transformation we get 0 0 minus 1 by 2 and minus 3 by 2. Then we have to multiply the third row by minus 2, then we get the new row 0 0 1 and 3. Now the augmented matrix is in echelon form. Therefore the rank of A, now we have to find rank of A, means only the rank of coefficient matrix, only the rank of coefficient matrix. And the rank of coefficient matrix, we know the definition of rank, the total number of non-zero rows, and here is 3 non-zero rows. Therefore the rank of A is 3. And same thing we have to find rank of this whole matrix, means rank of AB. Therefore the rank of AB is also 3, and there is a 3 unknowns. Therefore rank of A is equal to rank of AB is equal to 3, and this is the number of unknowns. Hence the system is consistent because rank of A is equal to rank of AB. Therefore system is consistent and has unique solution, because again number of unknowns are 3 and our rank is also 3. Therefore it has a unique solution. Then we write down the corresponding system of equation is x plus y plus 2z is equal to 9, y minus 7 by 2 z is equal to minus 17 by 2, and z is equal to 3. Now we get the values of z is 3 by using this value, z is equal to 3. From second equation we find the value of y, and again from this we get the values of y, and we have two values z and y. Now using these two values we get the values of x. After solving this equation we get x is equal to 1 and y is equal to 2 and z is equal to 3 is the solution of the system. Now I hope you got it, all of you. Thank you.